Okay, well, everybody, welcome back this fourth morning of the training on data management and hydrological modeling. Yesterday we started with an introduction to hydrology and hydrological modeling using WFlow, and we started to do the exercises. For today's agenda, we will continue with the exercises. We do it a bit in the same format. So I will show the exercise, I will explain it a little bit, and then you try to do it on your own. But first, before we go on, I would like to give you the floor to ask some open standing questions about yesterday's exercises or yesterday's theory. So please take this time to ask your questions about yesterday before we go on with the tutorials. So if there's any questions, please let me know. And also if you don't have a question, please also make that known by putting in the chat no questions.
Mark, I have a question.
Yes. Yeah, very good.
As you remember, I had a GIS 3.10 version, so when I wasn't able to add the raster data DM. So you recommended me to reinstall, right? To use 3.4 version. So I did the same thing and it's still not working.
Okay.
So it's like GDL invalid layer, so it says the same. So I don't know what can be the reason.
Well, then it becomes a bit more challenging because then what I think is that in your system settings of Windows, you might have a GDAL library in your path. Do you know where to find your Windows path? And otherwise, I can if you share your screen, or maybe I can share my screen. I will show you where to find it. Share screen. So in Windows, I'm not sure which version of Windows you have. Then environmental, edit the system environmental variables. Yes, I want to make changes. So here we have our system properties, and here I can set my environmental variables. And if I click on that, and there's here in the system variables, there's a path, and I can edit this one. And it might be that you have a GDAL library somewhere in your path, or that your QGIS bin is not in your path. So what you can do, maybe you installed QGIS, the new version, that you say I want to add a new one, and that you put the path to your QGIS bin folder in the path. Yeah, so then what happens is then Windows can find the binaries that it is actually requiring. So we can try that. So maybe you share your screen now, then I can try to help you.
Okay.
Yeah, so let me see. I indeed don't see a QGIS. Okay, so yeah, make a new one. And then maybe first copy paste the path to your QGIS bin. So I don't know where it is. Yeah, just go to C. No, this is just a this not. Just go to this PC, and then C, then program files. I think it's in the other one, so not the X6, not X86, but the other one. Yeah, that one. Yeah, and then bin, and then copy this path and add it to your a new one, and end with a slash. Slash. Yeah. Okay. Well, let's try now, and then open QGIS 4, the 3.4. It's I'm not 100% sure if it's gonna work, but let's try.
Can it be the reason that the path is consist of Cyrillic letters? I mean, the path of my user in computer?
Yeah, could be. And maybe another option in this, well, first try this one. Yeah.
Yeah.
Yeah. And then if you place this file, this wflow dem in a location where there's no Cyrillic letters.
No Cyrillic.
So just in C temp, for example, you make a temp directory on your C drive.
But the thing is that the username is Cyrillic, you know? When you go to, okay, let's try. It was in,
Yeah, indeed. So copy this one to a c.temp. c.temp. Yeah, just make a new folder. Yeah, and then put it in there. Oh, there's already a folder. Test, maybe call it test then. Yeah. Put it here, and then if you add this one. Test. So, yeah, there it is.
Now it should work. Oh, it works?
Yeah,
wow.
That works. Yeah. Okay, so then it's the path to where your model is stored that is the problem.
Okay.
So then it makes sense to move this whole folder to this test directory, I think.
The test directory. Okay. So. Yeah. Okay.
Yeah, and that's that's something where I think QGIS maybe was never used like that with the Cyrillic writing or so. I don't know.
Mm-hmm. Yeah. Mark, also one question.
Yeah.
Do you remember I sent a DM to you with you replied, but to be honest, I didn't properly understand. I just added I added your files, you know, but it didn't work for me. Why it can be like this? You know?
Sorry, what didn't work for you?
I mean, the thing you sent. Me. What was that? I mean, this folder, right? Model test zip.
Yeah.
So I okay, where it is?
Yeah, so it's you did unzip it here. So if you unzip it, yeah.
So so what should be next done? To be honest, I didn't get it.
Yeah, so what I did is in this prep model.cmd, if you open that in TextPad, in Notepad, oh, no, not run it, but open it with a right mouse click, and then open with edit with Notepad.
Okay.
Yeah. So here's the steps basically that I did. So first I translated the TIFF file to a map file. That's the first line. And then I use PC Raster, and I send you the link where you can download PC Raster to create all these maps, including the river map and the subcatch map. And I did this script, I run this script already, so all the maps are already there. So for example, you can now have a look at the rivers map or the stream order map that is in this folder.
And how to do this? Just to add the layer?
Yeah, you can just add the layer in QGIS.
Okay.
So just go to a new one.
Yeah.
Yeah, and then.
Is it raster, right?
Yeah, it's all rasters files. Yeah.
Okay, you. It was in 1 minute. Desktop.
Yeah.
Model test.
Yeah, and then you can do the, well, you can add the DM, of course, then you can add the rivers.map and the stream order.map.
Rivers.map and stream order map.
Yeah.
This?
Yeah, these three, for example, but you can add all of them if you want. Yeah, then you have the same issue, I guess, with the Cyrillic writing in this case.
If I add all of them, I mean, the streams are already delineated, yes?
Yeah,
right?
exactly.
Ah, okay. So, okay, I will try to change the path, right? And then what should I add? I mean, the things you just show now, right? These files? I want to write this.
This prep model.cmd.
Yeah. Then I add this like dim recep, rivers map and stream order.
Yeah, but you can also add the rivers.geojson because that is a shapefile of the rivers instead of a map file.
Instead of the map file. Okay.
Yeah, you can you try to add this river geojson now, because I think that might work directly. You can just drag it into QGIS.
1 minute.
Yeah.
Oh, it works.
Yeah. And then the only thing is you have to set the right coordinate system. So I think it will be added automatically to Bayesian.
It is, yeah.
Yeah, so that is not the correct one, so you should change it.
Vector.
No. Just on the rivers, right mouse click, and then set CRS.
Yeah.
And set layer CRS. Yeah. And then 343 north. Yeah. Okay. Yeah, wow. There it is.
Yeah, you're a magician. Wow. Wow. Okay.
Yeah.
Okay, this sounds.
And the same you can do for the basin. So I also have a basin.geojson, and that is then the catchment boundary basically.
Basin. Okay. Okay.
Basin, the top one, the top one.
Okay.
Yeah. You can also drag it in.
Yeah, I can try it.
Yeah. And then this one you have to also set to, yeah, perfect. Oh, you do a very nice demonstration, you know?
Yeah. Wow. Yeah. Okay. Overlay.
Yeah. Oh. Yeah, that's always, yeah.
Wow. That's great. Wow.
Yeah.
Okay.
And the nice thing, well, now we are busy, you can also do some styling of your rivers. So if you select your rivers layer, then this symbology.
Categorized?
Yeah. Graduated.
Graduated. Okay.
And then you can select the method, is now color, but you can change it to size. And then you can, from 0.1 to 1 instead of 2.
Okay.
Yeah, and then in the column, the top one, if you go to the top, you select stream order. And then you do classify on the, you go, yeah, almost there, on the left low, yeah, there. And it will take some time, but then it will classify your layer and then apply. Oh, yeah, no, go ahead. And then you see also the let's say the big rivers you can distinct from the smaller rivers.
Wow, okay.
Yeah.
Yeah, that's great. So now I can add my points, right? I mean the meteorological conditions, the
gorgeous. Yeah, exactly. Yeah.
Okay, wow, that's great. Thank you.
Yeah.
Come on.
And the script that I showed, this batch.cmd script. If you install PC Raster, you can basically do this steps for all your DEMs that you have automatically.
Oh, okay. So
yeah. So
I have the. Okay. That's great. Thank you.
Yeah.
Thank you a lot.
Well, no problem. No.
Googling it a lot, you know. I was even thinking to do it by myself, you know, deleting it one by one.
No, that is a tough job.
Yes.
Yeah.
You really helped me. Thank you.
Yeah, no problem. Nice to see. Okay. Are there other questions from the group? Okay. Well, then I suggest that I share my screen again, because then in that case I assume everybody was able to do the first two tutorials, install the software and explore the model. So I assume that for everyone the model is running now. So that means that we can go to the next tutorial, and that is basically changing the WFlow model setups. So I click on this one and we go to the next tutorial. And one of the things that we want to explore is what we call the ini file, the WFlow SBM ini file, because this file contains a lot of settings that we use in the model. So I'm going to show this ini file in a minute. But there's a lot of different sections, and there's saying something what is the input of my model, some things about the framework, says where is my input file located, what is the name of my output file, what is the type of my output, and there's you can describe your run, so you can say something about start time, end time, and time step. So I will just go to this ini file. Let me go here to, this is, you understand better, the projects, correct, training WFlow, tutorials, Moselle. And then we have here this ini file, WFlow SBM ini file. Then I can edit that one in Notepad, and then you see this file appearing. So indeed, this is a file that says something about how to run the model. Well, the first part says what is the name of the precipitation in my input file, and I know that in my netcdf input file the precipitation is called P, temperature is called temp, and evaporation is called PET. So this is how I can link to my netcdf file, but because in the model it is always called precipitation, temperature, or evapotranspiration, but in your input file it can have different names. So this is like an ID mapping. So this is the first part, input map stacks. The next part is about model parameters. And here you see different sections. For example, the first section is parameters that are linked to the leaf area index. And leaf area index is basically a climatology of canopy, this, let's say the canopy thickness. So you can imagine that in autumn and in winter the trees lose their canopy or their leaves, and in spring and summer they grow again. So you see that the leaf area index is high in spring and summer and low in autumn and winter. And some of these parameters are linked then to this LAI maps, and that is what we describe here. There's a section about lakes. So here we say something, well, we have the lake locations are read from WFlow lakes.map. Then we have an area map, which is located in the WFlow lake areas.map. And then there's some, basically some table settings, how, where the parameters of these different lakes can be found in which table, etc. So this is all about the lake parameters. If there would be reservoirs in our model, then we would also have a reservoir section here under the model parameters. Then the next part is about the run. So here we actually describe how to run the model. And here we have a start time and an end time. And here you see that we have run the model from the 1st of January 2015 till the 30th of June 2015. So if we want to change that, we change it here. So here we can change the settings of the model. Well, we can also say something about the time step of the model. In this case, it's 86,400 seconds, which is the same as 1 day. And of course, your time step should match with the input data that you have. So we provided the netcdf file with the precipitation and temperature input on a daily basis, so your model can only run on a daily time step in that case. We have also a re-init option. In this case, it says 0. You can also put this option to 1. And re-init means that you can reinitialize the model when you start running. And reinitialize means Normally, if you build a new model, you have no clue, let's say, how much water is already in your model when you start running. So then you start running with an empty model or a cold model, so how it is called also. So the initial condition or the initial state of your model is cold in that case. If we have run the model, we can also store at the end of that run the situation or the state of the model, how it is at that time, how it is at that time. So then we can save the state, and we can also decide to start a new run from this initial state. And then if that's in that case, we call it a warm state. And here we can basically say if we want to start with a warm state, then we don't reinitialize the model, or we start with a cold state, then I reinitialize the model, and then I start with an empty model. So that is this section. Well, this one you don't need to change. Then we have some parameters of the model itself, about the kinematic wave time step and the iterations in the kinematic wave. I would keep them as is for the moment. And then we have some information about the framework. So here we say where is my netcdf input located. So that is in maps forcing ER5. So if I can also show that is in immaps, and that is this file. So that is described here in this netcdf input argument. Well, the netcdf output name wflow outputs.nc. Well, we write in a netcdf4 format. The EPSG code or the projection is lat long, so that's the 4326 EPSG code, and this says something about the size of the buffer that we write the data. Well, size in meters, that is only one if you have a projected coordinate system. In this case, we have a model that is not projected, so it's in lat long, so the size is not in meters but in degrees. And then we go to the outmaps, but that's already, I think, the second part of this exercise. So what I suggest is that you explore the model setups yourself, try to understand what is inside, and then we change the simulation time to run the model not for a short period but for a longer period. So in this case, I suggest to run it for 1 year. So we change basically the end time till the 31st of December 2015. Yeah, and then you can try and rerun the model, and then see if that is indeed working. Okay. Yeah, and then the next step would be, because now we said something about which variables did we change, save already in the output file, but you can save more output than just this. So the next step is that we change this so that we also store some other output. So if you are comfortable, you can continue already to the next step, but for now, let's say, make it at least sure that you can run the model now for 1 year by changing the simulation time. Okay, so back to you to start working on this. Yeah, go ahead.
Вот мы же тут меняем, да, начало и конец, старт и end time. Изначально у меня тут было написано end time до 06:01, значит, до 1 июня. Значит, у меня вчера он посчитал до июня, да?
Okay.
Теперь я должна тут start time у нас в этом.
That was in the original file, yes.
Да, в туториале было написано до, а start time надо было изменить с 1 февраля. Теперь я могу изменить с 1 июля, да, 07:01. Или мне надо запустить сначала на 1 месяц, на январь, потом только...
Yes. Yeah, exactly. I'm gonna share my screen. Yeah, so if you are in the wflow ini file, you have here the start time, and we keep the start time as is, and the end time, I changed it here to 2015 12/31, so that is the end of December. It was like this in your file, and I just change it till the end of December, and then I save it, and then I basically run the model again by just double clicking on this one, and then you see that the model is starting, and now my model is running, and the first 100 time steps are now finished. So you see now it's running for 365 time steps, so that is indeed 1 year. Yeah, so in this Wflow ini file, you say start time is 2015-01-01, end time 2015-12-31. Is that clear?
Да, теперь все понятно. Просто я, кажется, запуталась, потому что
Okay,
я после
perfect.
каждого шага в туториале надо было запускать модель, да? После каждого шага в туториале мы запускаем модель, правильно? Например, изменение времени.
You are not in. Yeah. Exactly. Yeah, exactly. So we change the simulation time and we run the model. Then we change the variables and we can rerun the model. Yeah, so that is how it works. And I will just show you step by step the different options that we go through. So first, maybe just run the model to see if it's indeed running for the first year.
Спасибо, теперь понятно.
Okay, good. Okay, well, I'm gonna show a little bit more steps now from this tutorial. So I showed how to change your simulation time. Well, my model is still running, so in the meanwhile I'll go to the next part. Is about changing the saved variables. So if we go back to the ini file, I stopped here at the section at the layout section, but you see that below that there's also everything about output. So first of all, the Wflow model can output maps. So in this section, the output map section, I can actually say which maps to store, which parameters. And you see that in this case, all the sections that are without a hashtag, so in this case self.snow, are in the end stored in my output.cdf file, which is described here. So in this case, in this model for the Moselle, we save snow, we save the water level in the kinematic wave, we save river runoff, we save land runoff. So those are the 4 parameters that are actually on at this moment turned on. If I want to store more parameters, I can just turn them on. So for example, if I want to know how much canopy storage is there, so I can turn on the canopy storage. If I want to know how much infiltration of paved areas there is, or how much infiltration of unpaved areas there is, I turn those on. Maybe there's something about evaporation. So maybe I want to say, let's see, which one shall I turn on? Yeah, so maybe this one, I turn on the sum of the evaporation from the saturated store. So I can now turn all these on, and I can save and my ini file, and I can actually do a new run. And since you saw that the model is quite slow, I change back the time setting. So I am now going to run just for 1 month. So I change my end time again back to the first, in this case, to the end of January. So now the model, if I start it, will run for just 1 month. So now I saved my extra output. And I can do a run again. So I go back to my folder here, tutorials, and I can basically double click my run hydrology Moselle. If I want to store my results, I can also open this with right mouse click, edit in Notepad, because as you remember yesterday, we explored this this command line interface. So here is the path to my executable, the case I want to run, so in this case the Wflow Moselle, and here's the name of my run that I want to give. So in this case I gave my run the name SBM 2015 gauge 1 year. I go now to rename it to 1 month, changed output. So this is going to be now the name of my folder where the output is going to be stored. So I save this one. In the meanwhile, the old run is finished. So I can go back here. I can double click. And now remove this one. It's starting up again. So let's wait to see if my start time, end time indeed was set correctly. So the initialization sometimes takes a bit of time, but once the model is running, it's okay. So let's wait till the model is running. Yeah, so the model is started, and I see now indeed that the model is at time step 3 of 31. So indeed my end time was changed, so I'm now running only for 1 month. Just to see if my changes in the output variables are did come through. I already see, by the way, that these variables are now added to my netcdf file. So it looks like all these added parameters are going to be stored in my netcdf file. So that looks good. So this was basically the next part, changing the saved variables in the out maps. So that is something that you can try. Yeah, and I think that is the last thing that I want to show. Well, maybe one more thing, because as I said, it's not only the out maps that we save, but there's also, we can save some summary maps. So we can also say summary sum, so I can have at the end of my run a file that has the sum of the precipitation of the whole simulation, or the maximum in the simulation, or the minimum, or the average. So in this case, I save my sum precipitation, maximum precipitation, maximum temperature, minimum temperature, and the average precipitation. But I can also add some extra files here. So I can, for example, use the same. I can also do a average river runoff. So run r average dot map. So then I will get a map with the average runoff, river runoff. I can do the same by adding land runoff. Run L average. Yeah, so I can add all these files as a basically as a summary at the end of the file of the run. And then there's the output CSV section, and that actually saves time series. And in this case, how it works, well, you always have like a sample map, so that points to a map file in the static maps directory, and that can either be a point location or like a subcatchment. And then I can save on this point, for example, I can save the river runoff and the water level and the kilometer wave volume. So for all the points in my Wflow gauges map, I will get a time series for each point describing this parameter. And for a Wflow subcatchment map, which is of course, yeah, that's more coverage, I can also store snow and precipitation. So then I get the average precipitation per subcatchment as a time series. And of course, that's very interesting information to know and to analyze. So also here, if I want, I can add all kinds of time series output that I want. And you see that I can store, for example, per subcatchment the average, but I can also do this per land use type. So if I want to analyze in more detail what's happening per land use type or per soil type, or basically per any map that I can define, I can supply the map as a sample map, and then I can say, well, I want to see the time series for every class basically in my map. So that is how this time series output works. Yeah, so what I did now, I added some summary maps. I think my Wflow model for 1 month is finished again. So I want to do one more run where I save these extra average, the summary maps. So I call it, give it another name. So now I change my output directory and I do one more run. So it's starting again, and in the meanwhile I can have a look in my folder, and I see indeed I have the first run I did, then I did a 1 year run, then I did a 1 month run with changed output, and now a new folder is created for my 1 month run changed output 2. And that is now starting up, so then I think it will be finished within a few minutes. If I want to visualize the results, I can use the exercise of yesterday using QGIS, and I can, for example, just load this Wflow outputs netcdf. So I'm going to do that. So I'm going to start up QGIS. Okay. That will take some time. In the meanwhile, check my model. It's almost starting, I think. It's just initializing the model before it starts running. Okay, I think QGIS should also start up now. Yeah, so the model is at least starting. Yeah, there's my QGIS. So I'm gonna add a new layer, mesh layer. So that is projects, Carec, Wflow tutorials, Wflow Moselle. Well, let's look at this one for 1 year of output. Add. This will take a bit of time to load, but then we can also look at the results. Yeah, so that is my first one that I want to add, and I want to add also the results of my 1 month changed output. So that's this one, to see if we indeed have extra output variables stored now. Yeah, perfect. So I have now two netcdf files. So this is the one that is data for 1 year. So there I have the level in the kinematic reservoir, land runoff, river runoff, and snow. And in the second run, I added a few parameters, and you see that indeed I have now more parameters stored in my netcdf file, including canopy storage, for example. Make this a bit bigger. Yeah, and then we see that there's some results for this parameter. Yeah, and of course it's only 1 month of data, so it's not a lot of storage that will take place in this case. Maybe snow, there's more. Yeah, snow we indeed, but that we had already. Maybe evaporation. Yeah, so evaporation we have now stored in the netcdf file, so that is nice to see, because evaporation is also one of these data sets that we can actually use in the validation of the model, because we can compare it to Earth observations, to satellite data. So indeed we see now that that we can add output to the netcdf file, and we can visualize that again in QGIS. And then the last thing I wanted to show was that, and my run is finished, is that I have extra summary maps. Oh, that's the wrong one. So go back to this one, and that was stored in the last folder that was created, because the netcdf file is stored here, but we also have an outsum directory here, and that is a summary that stores all the summary maps. Yeah, and then here I have a run R and run L average.map, so I can also add them to QGIS. You can just drag and drop. So this is the average river runoff and the average land runoff. Yeah, and then we can maybe make a nice map. So I do the land runoff first. I add a 0 no data value, because 0 I don't want to see. Then I do a single bond pseudocode for this one, blues. This is my river runoff. One, yeah. Yeah, so then here we have the average river runoff. Well, the land runoff, I make then maybe red. And also here I say 0 is missing value. So here now I see I have a nice combination of my average river, the land runoff, and my average river runoff, and that is of course could be nice also again for reporting your modeling results. And you can basically see from every pixel in the model, we know now what is the average runoff over the simulation period. And if I use my value tool, which is one of the tools that you can install, the it's a plugin that you can install, I can actually inspect the values by just hovering over the grid. And then you see, for example, this tributary in this simulation has a river runoff, run R average of 11.5 cubic meters per second, and the main river here has an average river runoff of around 340 cubic meters per second. And this is this can then provide you a lot of information. And if you add, for example, your gauging stations to this map, then you can actually see what is the average runoff for each of the locations. And I now added here in the ini file the summary average. I added them. I can also, of course, add them to my maximum. So I can also say what is the maximum river runoff in my simulation and the maximum land runoff in my simulation. So this is also another way of producing some nice output that can be very helpful in the analysis of your model. So this is how you can change your outputs in the ini file. It's described more or less in the exercise here, changing the saved variables. I would suggest to change your end time back to the end of January, just to test if it's working, because otherwise we have to wait every time very long for the simulation to be finished. Okay, that's something I wanted to show on the screen while going through it together. And well, I hope you managed to also do this yourself, just by changing some of the settings in the ini file, rerunning the model, and analyzing the results in QGIS. If there's any questions, please let me know, and otherwise you can continue with the exercise.
Если название папки выходного файла я оставила таким же, значит, он у меня уже перезаписывал, да, результаты?
I think normally it should give a warning that that it should not overwrite, but we can test it. I will share my screen because normally it should not overwrite. You can force it to overwrite, but for example, I now created this this map, this folder. I'm gonna remove all this so that it can be overwritten if needed. So basically I can, I didn't change anything now to my, to my settings. So I'm just gonna run it again and see what happens. And I think it should not overwrite, but it looks like it does. Yeah, so apparently it is overwriting it. So then I think now this one is yeah, it's overwriting. So that is good to know. And that apparently that changed in the latest release of the WFlow model, because in the past you would get an error that it is trying to overwrite something. So that's something I will provide feedback to the developers, because it's nice to get a warning if you overwrite a model. Did I supply? No. Yeah, because normally you could supply an argument here that says force override -F, but apparently that's not needed anymore. So indeed, be careful that if you don't change the output name, it will overwrite your files. Any other questions?
Вот при расчете у вас никакие ошибки или warning messages, такие ничего не входит, да, у вас? У меня были некоторые моменты, где warning было написано, предупреждение. Это нормально?
Yeah, yeah. Yes, of course, yeah. I can make a mistake. Let's just try one. For example, I can change this one. I add a parameter self.snow2, and snow2 is not in the model, so this parameter doesn't exist. So I would say that I get a warning if I run like this. So let's try if that is the case. So then we just run. Then either a warning or an error message. So it will need some time before it reaches this point, because it's first initializing the model, so it's basically setting up the model in memory, and then once it starts running, it starts looking in what output should be created, and then if it cannot find it, it will probably throw a warning or an error, but I'm not. I wonder if I'm now, yeah, so maybe here, can I? So here I see now in the log messages there's a warning indeed. So it tells me there's, I start saving the maps, and then it starts creating the variables one by one in the output file. So it's creating the variable snow in the netcdf file, and then it throws here a warning: output map self.snow.2 is not found in the user model. So this parameter, it gives me a warning that this parameter doesn't exist in the user model. well, it does run in the end with it, but it keeps throwing this warning. Well, I cannot save this variable because it is not in my model. So that is a way how this works. I can maybe also really get it to crash. It's also interesting, of course. So then maybe, then for example, netcdf input, if I say, well, it is not in maps, but it is so I forget to point to the InMaps directory, so I say, well, my forcing is this, but it's pointing to the wrong location. Let's try and run it again. Yeah, now it gives an error. So here it says error that this file forcing ER5 cannot be found, and then you don't have any input to your model. So then basically the model crashes. But then it says here in the log message that it cannot find this file, and if I look at this location, I will not find it because it's in the folder InMaps. That's where we stored it. So this is another way of getting feedback from the model while running it. Does that answer your question?
Да, спасибо, но я ничего такого не меняла. Я запускала с теми параметрами, которые там были изначально, но у меня были такие сообщения.
Yeah. Yeah. Okay. Can you then maybe show your screen to show what you mean?
Я уже закрыла это окошко, но сейчас я собираюсь запустить еще раз, уже поменяв название папки. И если будут такие же ошибки, я сейчас сделаю демонстрацию.
Yeah, perfect. I see someone is sharing the screen. Is there a question? Because I don't hear anything. Yeah. Okay. Yeah, I see. Can you select the group? So that's and then select. Yeah, that looks good. And if you go back, from map indeed. Yeah, so it's not. Can you just hover over the grid, but just hold your mouse for a moment. So put your mouse on top of the rainfall grid, and then keep it there for a moment. Oh no, on the map. Yeah, keep it there. Just hold your mouse still. Maybe it just needs some time. And that is weird.
Можно спросить?
I don't know the answer to this one yet.
Почему мы в названиях входного файла C на R? После этого у меня ошибка выдает.
Sorry, what was the question? If you select current here. Yeah, maybe can you time series? If you on the left panel. Yeah, if you go back, if you hover over the grid again, but then not click on the map, just hover. And if you click on from map below, if you click again on from map, is there a way that you can give me control over your screen or not? Remote request, yeah. Okay. Yeah, okay, so here, this one indeed. P. Because I have the feeling it is zoomed in very much. View all. Okay. Let's try again. Yeah, I don't know. It's a good version, huh? Let me try again. So I'm gonna remove the layer. Then we're gonna add it again. Add. And that will take a bit of time. Okay. Close. I have no idea why it's not working. Yeah, because I have the feeling that it is to do with the axis. Yeah, that's it. Okay, I think we solved it. It was just that the time axis was completely zoomed out. So now I think it does work. Yeah. Okay, and now let's say precipitation also works. And then I should select here current. Yeah, then precipitation also works. Okay. Yeah, so I solved it. Right mouse click on the graph, x-axis, and set it to auto for scaling and y-axis to auto for scaling. Yeah? Okay, then I'll give back control. All right. There was also another question I heard.
Да, у меня был вопрос по поводу R и C options. В чем их разница? Почему мы его меняем?
Which option?
Вот в названиях выходного файла мы меняем букву R и C. В туториале написано.
Let me see what the tutorial says.
C option и R option.
Yeah. So let me share my screen. There. Yeah. So in the tutorials folder, you have two models, Wflow Carrot, Wflow Moselle, and you have these batch files. There's two types of files that we change in this tutorial. One is the ini file that describes here, that is in the model directory, and that describes the configuration basically of the model. And if you go one up, then we have these other files which are called the run hydrology.bat. And here we actually run the model with. So we can, for example, this one, we can select right mouse click, edit with notepad. And then here we have this -C and this -R option. And we point to the ini file. So we change the ini file to say something about what we want to change in the output. And in the run hydrology moselle.bat, we change the name of the output directory, the -R option. Does that answer your question?
Да, можно я сделаю демонстрацию экрана? Мне ошибку показывает.
Sure. Yeah, go ahead. Okay, yeah, so there an error. Okay. Yeah, I see. Because if you look at your that one indeed, the run hydrology moselle.bat, you change this file and named it -r, but the first one is a minus capital C. Yeah, that says case, and that one is small c. Yeah, exactly. And now, and what? Sorry, one more thing. I see that you in the after the -r option, SBM. That should be the name, but you have spaces now between changed and variables and gauge. So replace the spaces there with a hyphen. Yeah. Just add a minus sign there or so. And also after changed and variables. Yeah, like that, and there as well. Underscore. Yeah, this looks good. So I think now you can try it again to run this batch file, and then hopefully your error disappears. Yeah, double click. Well, let's see. I don't see anything happening yet. Did you press the double? Did you double click? Yeah, there it's coming. Yeah, it might take some time to start. It takes a long time. Yeah. Yeah, this looks much better. So now it seems to be starting up at least. Okay, well, this looks good. So
У меня тут warning messages.
yeah, so these warning messages indeed. That yeah, you have to be a bit experienced in using Wflow, because basically these warning messages say that the some tables cannot be found, and that it will go to the default value. But some of these tables, yeah, you don't have any information anyway to provide a better estimate, so then the default value is actually okay. But here you see indeed that for some parameters, it will just go to the default. For example, the max percolation.tbl is missing, but then you see it just returns to the default, which is 0, and that is quite okay.
Thank you. Марк, можно спросить, в рамках семинара мы будем изучать, как подготовить входные параметры, входные файлы, input files?
Yeah, sorry. So for this workshop, we focus now on using the model, and in the next tutorials, we will also add some input maps or change some input maps. So we will continue with that today and maybe even tomorrow. Setting up completely from scratch is not included in this workshop, but we will, for example, and maybe I'll show on the screen in the tutorials. Because we've then now basically done the first part, and then we start to the next part, creating your land use map, forcing data we might skip, but for example adding water bodies to the model. So first changing or adding the land use map, that is the first exercise, let's say, after we finalize this section. So this is how we show how you can prepare a land use map to be used in the model. And the other exercise, adding water bodies to the model, is about creating a lake and reservoir map files to be added to the model. So so that is this exercise. So this is all included in this tutorial. But some parts we skip because then that might take too much time to go into details. But we can maybe revisit this part in further training during this project. So yes, partly we will build some maps that that we will use in the rest of the tutorials, and partly we keep working with the maps that are already there. Okay. Does that answer the question?
Да, хорошо, спасибо.
Well, maybe it's also then time for a quick cup of coffee. So then we take a 10-minute break, and then after the break we continue with this exercise actually to create the Wflow land use map. Okay? Then we are back at 10:55. Okay? All right. See you in 10 minutes. Okay. Yeah, let's maybe continue for the last hour of the day with the next tutorial. So let me share my screen, because what do we want to do? Yeah, so I suggest that we move to the next tutorial to create the Wflow land use map. So I open the tutorial, and this one is about adding a new map layer to the model. So we're going to prepare this map layer to be used in the Wflow model. Because if we look in the model, so we have Wflow model static maps, and we have Wflow land use map. We have it here, but if I open this map, it's not okay. It's already there, and it doesn't matter. But we are gonna create this new map based on the GlobCover dataset, and GlobCover is a globally available land use dataset. So we're gonna open a part of this map which covers the Rhine in QGIS. So that's the first step, is opening the GlobCover, and it should be in the data folder. So let's go there. data. So there's a indeed glob cover Rhine.tif. So I'm gonna open this one in my map, and you see that it covers quite a large part of the model of Europe actually, because if I add also my Wflow Moselle Wflow DEM on top of it, then you see that my DEM only is only a small part, let's say, of this global of this land cover map based on glob cover. So I added now glob cover to the map. So I go back to the tutorial. Of course, you see that it is a gray styling, so we can also do the styling based on a different classification. So we can go to the symbology tab, and then we go to rescale or we change a different to pseudo color scale, and we are going to add a glob cover legend.text. Okay, so let's try to see what is there. So we go to properties, symbology. So we go to a single bound pseudo color, yeah, and then let me see, what does the tutorial say? Yeah, load color map from file, so that is this button, and then there should be a glob cover legend.text open. Yeah, and now we see that indeed we have a classification and a description for the different land use classes. Apply, okay, and now I see that we have a nicely styled layer, and here I can also see now the different land cover types. So I can also turn off my Wflow DEM, and I can explore. So for example, this yellow color has the value 14, and in my legend I see that is rain-fed croplands, and the green color is 50, and that is closed broadleaf deciduous forest. So you see that based on this map I can distinguish between different land cover types. This red one, what is that? 190. Artificial services and associated areas. So that is urban areas. Well, let's see if that is if we can recognize this area also on the map. So let me add maybe oh sorry, that is here. Quick map services OSM standard. No. No, it should be here. So I would expect, yeah. So I see indeed, if I look on the map, it's an urban area. So I see that also in my land cover map. And of course, this is important information because an urban area does react differently on rainfall than a natural area. So this land cover map is quite important. So we're going to use this map now for our hydrological model. So we've done the first steps in the tutorial. Then we're going to resample the map to the resolution basically and the extent of our Wflow map. So we add the Wflow subcache map to our folder. So that is Wflow subcache. So I drag it just into my system. So I have now my subcache map. And in the tutorial it says go to the raster projection warp to open the resampling tool. So that is located here. So in QGIS it's raster conversion projections warp. Yeah, so here it is. I open it and then this window pops up. So then I look at the tutorial. and I'm gonna basically copy paste what is set in this this box. So the input layer is our glob cover map, source SRS, well, it's lat.lon, so WGS84. We want to keep that, so the target is the same. The resampling, we use the mode. What is the difference? Well, nearest neighbor, it just looks at the nearest neighbor and does some averaging. And mode means that we want the new map to have as output value for each grid cell the value of the mostly available value in the base data set. So we use the mode resampling. No data set, well, no data we keep as is. Output file resolution 0.008333. So we let me see, what is it? Yeah, 0.08333. Is that correct? 00833. Yeah, it is. Oh, sorry, I pressed OK. That was not what I wanted to do. I'm gonna remove this layer. Yeah, no, I should not have done that. So warp, do it again, basically. Yeah, mode, no data, 0.008333. Okay. Then we keep this empty. Output data type, well, use input layer data type. Yeah, that we keep here. The extent, here what we do is we press this button here and we select use layer extent, and then we select the WFlow subcache map. So then you see that it will automatically find the minimum and maximum extent of the subcache map, and that we make sure that the output file matches completely with our WFlow model grid, which is important. CRS of the target raster, also this one, and I think that's it. Yeah, and then we can say we want to save it somewhere, so we save it to file, and then training WFlow tutorials, WFlow Mozilla, and then I create a folder, new maps, for example. Sorry, one up. New maps, and then we call it Mozilla landuse.tif. Okay, save, and now I can run. So hopefully this, oh, it's already finished. So close. So I can remove this layer, and I'm gonna add my new file, new maps. So yeah, it's located here. So you see now I have a new map, which is the land use. It has the same classification basically as my glob cover map, but it is for a smaller extent, and it's exactly the extent that covers my my WFlow model. So you see that my WFlow model exactly fits to this map. So that's nice. I can also make a nice styling. So I copy the style from my glob cover, and I paste the style to my land use, and then I have now my land use map resampled to the extent and the resolution of my WFlow model. Yeah, so this is then basically the start of making my WFlow land use map. So that was the first step. Yeah, so this is about the styling, and now we want to save it as a PC raster map, because the WFlow model needs PC raster input maps. So therefore we use the translate option, and then I'm gonna just copy paste what's in this box. So I'm gonna go, I select WFlow land use, then raster, conversion, translate. Yeah, so then this box pops up. So my input layer is the Mozilla land use. So I want to use the WGS84 projection for the output file. There's no data value, but we need to add a PC raster value scale because PC raster value scale, I just write it like this, is value scale scalar. And let me see if I did that correctly. PC raster value scale vs scalar. Yeah, so that is correct, I think. Output data type float 32. So I'm going to force that it's going to be float 32. And then I save it to wflow land use map. Save to file. Make sure it is in PC raster format. Where is that? It's always difficult to find, but it should be the map. Where is it? Where is it? Yeah, there it is. Map file wflow land use dot. Yeah, so like this. Save. Yeah, so it's saved here as land use map PC. Yeah, I think we can run this this command now. Run. Yeah, it was translated. Close. And yeah, QJS now adds always the temporary file, so I'm going to skip that. So I see now a wflow land use map, so I can also drag it into my QGIS, and you see that again it's nicely covering the same area because it's basically a copy of the Moselle land use, but then only stored in PC raster format instead of GeoTIFF format. So again, I can also do the styling. So I say right mouse click, style, copy style, right mouse click, style, paste style, and now I have my wflow land use map, which can be used in my wflow model as input. Yeah, so this is basically the tutorial to create a new map, a wflow land use map to be used in your wflow model. So I hope that is clear. The steps are nicely presented here in the tutorial. Especially look carefully also on the screen dumps. Here you can very clearly see the settings that you need to set to create the maps as is required by the model. I think that's what I wanted to show, and I think it's nice if you can try to prepare this map yourself based on the exercise in the tutorial. Okay. If there's questions, please let me know, and otherwise, yeah, just get to work and try to do this specific exercise. Okay, yeah, maybe that's a good question. I'll show my screen because that is indeed not completely clear in the tutorial. In the folder, in the tutorial it says run hydrology.bat, but since we have two models, I prepared two batch files, one run hydrology carrack.bat and one run hydrology moselle.bat. So if you want to run the Moselle model, you use this batch file to run it. Yeah, so this one should be there. That will run the wflow Moselle model, and this run hydrology carrack does run the carrack model, which is an extra model that can be run if you're done with the tutorials for the Moselle. But yeah, so that's true. In the tutorial, it just says run hydrology.bat. So sorry for being unclear. You actually need to run hydrology moselle.bat. Does that answer the question? So how is everybody doing? Making progress with the tutorials? Okay. Well, then I suggest that because it's almost time to call it a day, that I just that we wrap up this this session for now. I have the feeling if I show another exercise that might confuse you, so I suggest to start with that tomorrow morning. So for now, I would suggest everybody to, well, just see how you progress, collect all the questions you have, so then we can look at them tomorrow morning together, and then tomorrow morning we will go to, I think, the final tutorial we will do in this session. So that's adding a water bodies to the model. So in this exercise we will add lakes and reservoirs to the model. That is a nice exercise on how to do this. And you see it's quite a long exercise actually. So that is might be nice for tomorrow morning. And then the second part of tomorrow, I suggest we focus more on integrating the WFlow models into Fuse. So I prepared an exercise for that tomorrow, where I can demonstrate how we integrated two models actually for the region that you are working in, that were set up already. So then you have at the end of tomorrow a Fuse application including two hydrological models for your region that you are able to run from Fuse. And based on the exercise that we did today, you might also be able to run it outside of Fuse and change some of the settings in your model. So that we keep for tomorrow. For now, then I wish you a very nice evening, and I hope everybody still has the energy to go on tomorrow with the final session on data management and hydrological modeling using Fuse and WFlow. So thanks for participation today, and see you then tomorrow.